students, my dear energetic physics enthusiasts. So the 2024 NSE paper happened few months back, and since then I have received many messages on Telegram, sir, discuss Karlo paper, and I was like, internet is flooded with those solutions. So what do you want me to do? Because everybody just go to Google. There are a lot of solutions available for 2024 paper. And some students said, sir, नहीं आपका तरीका जो होता है बड़ा simplified होता है. So why don't you just discuss questions on this? So again, so that was the ideology behind bringing up this series. So today in part one, we'll do 5 questions, and we'll go in sequential order. So we are not actually focusing on topic by topic. We are going to start from question number one. Now, before I start, obviously a brief introduction about me. My name is Bhavdeep Sethi, and I have done masters from IIT Bombay. And since I graduated, I was actually working in corporate sector first, but then I had a passion for physics. So I converted to a full-time teacher long time back, and I have been converting physics haters to physics lovers since then. And I always say nature is the best textbook for physics, with due respect and love to all the wonderful books out there. But there is one book which is the best, and that is the nature. Now, obviously, as in my other sessions, you should never expect any spoon feeding. So if you are expecting that I'll be giving you the question and solving it for you, well, internet is flooded with those solutions. So you don't have to come to this session. This session is for not spoon feeding. It is about we look at the question, we go through the concept of that. I give you some tips and tricks or clues on that, and then you take it further. You solve it completely. So without wasting any time, this is the first question in one of the sets, I think set 64. So I just chose that set, and we'll start from the first question itself. Question is very beautiful, by the way. It says an air-filled parallel plate capacitor, parallel plate capacitor. So let's make that. So there is an air-filled. I'll rather go for the white color here. So an air-filled capacitor here with a plate area of A and plate depth separation of D. So this is from here to here is D. Okay, so that distance is D, a regular, right? Is connected to a battery of EMF V. So let's say we connected to a battery of EMF V. Perfect. Okay. One of the plates of the capacitor vibrates with an amplitude A, where A is very less compared to D. So this plate is now oscillating at an angular frequency of omega. If the instantaneous current in the circuit reaches a maximum value of I naught, the amplitude of the variations is the amplitude A is equal to, there's a typo I guess there, so one of these. So see what happens, let's say you have a capacitor, let's go for the concept here, solution to ho jayega. So there is a capacitor here, you connect to the battery. Over a period of time, it is going to acquire voltage V and a charge of C times of V, right? So it will have a charge of C times of V, and now it is stable. But see, as this oscillates, this distance D decreases and increases. So as D fluctuates, the capacitance also fluctuates. So charge that is C times of V, voltage being constant, capacitance is changing. So the charge is changing. So in order to change the charge, the current has to flow. And they're saying, okay, what is the relationship between all those? So let's start with how do we start? So charge is equal to CV. Voltage is constant. If the current is changing, sorry, if the capacitance is changing, the charge will change. And the rate of change of charge, you can say, is the current. So I can say, oh, how much is the current? Current is dq by dt. Now this V is constant, so I'll plug that out. The d by dt of C. Now what is C? C is epsilon naught A by distance. So even that I'll take it out because epsilon naught A is a constant. So epsilon naught A d by dt of 1 by d, can I say? Now it looks funny kind of there. So d and d. If I were to make the question, I would have said this is x, but that's okay because it's d. This d is for the derivative, and this d is basically the distance out there. So now obviously it's the change with respect to, so how do I do? So I can use the chain rule here. So if I use the chain rule, this becomes 1 by d square and then dd by dt, right? So basically, using the chain rule, what you get is 1 by d square, where d is the distance. So 1 by d square, d by dt of d. I mean, this d is confusing, but that d is the distance over there. Now, what is d by dd of d? Now, this d, it's fluctuating with amplitude a and a frequency of omega. So, can I say d is equal to a sine omega t? It's a sinusoidal oscillation there. Now, what is d by dt of this? You take the derivative of this, you get a omega cos omega t. So derivative of this with respect to time is this. So this actually can be replaced with a omega cos omega t. So a omega cos omega t, but that they're saying maximum current. So this is the current as a function of time. Let me write it cos omega t. They're saying the maximum value is I naught. So when will the value be maximum? When cos omega t is 1. So if I can erase this out, this is 1. So this is I naught. So this is the expression. You just just take the things here and a one of these will match. I think this is matching. Oh no, this is matching. Right, because I naught d square epsilon naught v omega a. So option A is matching. Okay, let's move on to question number 2 here. Now this one is very easy. Honestly, I didn't want to put it here, but because we are going sequentially, so I have put it here. This is most of the students here would memorize this answer is B. Basically, the point is this is the thread, and what velocity should you impart here so that it completes the circle? In order to complete the circle, obviously here the tension has to be 0. So that mg has to be m. So mg is equal to m u square by length of the string, where u is the velocity at that point. Let's not call it mass cancels out. So velocity at this point has to be root gl. If the velocity there is root gl, has to be root gl, then you apply conservation of energy. So half m, so let's write it down. So half m, this velocity square, that is gl, plus the potential energy here, which is mgl, should be equal to the kinetic here, assuming this potential reference is 0. So half m u square. And you solve it, this is 3 by 2. So first of all, masses cancel out. So 3 by 2 GL, 2 cancels out, root 3 GL is your answer. This is a very easy question. I mean, honestly, I didn't want to put it here, but because it was part of the paper, I just want to go sequentially. Now, this is a good question I would focus more on. So an illuminated point object is placed on the principal axis in front of an equiconvex lens, correct? Of focal length 40 centimeter. At a distance of u is 1.2 meters. So remember that centimeter, that's meters. So 120 centimeter out there from the lens. So let's make it. So let's make the diagram here. So basically the situation is more like, okay, there is a lens here, maybe there's a lens here, and then there is a focal point somewhere, and then there is an object here at a distance of 120. So this is going to form some image here. So let's first find that. So if I say in this case u is negative 120, so u is negative 120 and focal length is positive 40. So you use 1 by f is equal to 1 by v minus 1 by u, so that becomes plus 1 by 20. And then you bring it on this side. So v is coming out to be 60 centimeters. So this actually makes an image at 60 here. So this is the image made by the lens. Okay. A reflecting plane mirror has been placed behind the lens perpendicular to the principal axis. So let's put some mirror here. Mirror on the wall. So there is a mirror at some distance. We don't know. We are not told that. So it has been placed perpendicular and facing the lens. Okay. The nature of the final image and the distance of the plane mirror from the lens so as to form the final image at the plane mirror itself. Okay, what will happen now is this object makes an image here, the rays of light continue and they bounce off of this mirror and they go off through this lens. So there's a refraction, reflection, and then refraction. They're saying the final image has to be formed on this mirror. So what we are saying is, okay, this forms an image here. Now this object, this image will behave as an object for this. So assuming, so we have to find this x. So assuming this is x, this is x minus 60, right? This is x, this is 60. So this is x minus 60. So this plane mirror will form an image here at a distance of x minus 60. Come on, this is basic case, like plane mirror object is x minus 60, so image is x minus 60. So this mirror forms an image here. Now this image works as an object for this on the way back. So they're saying this object should make an image here. Very easy. So let's change the sign convention. This side is positive. So object distance is x plus x minus 60. So that is 2x minus 60, but that is negative. So let's wipe this out so that we have some room here. Let's clean. So now this is initial, so I'm saying initial velocity. What am I even thinking? Physics is so funny when same symbols used many places, and when you're thinking of physics, sometimes you're lost also. I'm really sorry for that. So this object distance is x plus x, that is 2x minus 60. So negative of 2x minus 60, that is the object distance. They're saying for this object distance, they should do something so that the image is formed here. So image is negative x. So v is negative x. And then they're saying, okay, focal length we know is positive 40 because it's convex anyways. Now you plug all this here and here, you'll get a quadratic. And again, as I said, I'm not going to spoon feed here. You have to work yourself. I'm just giving you the pointers. So what you will end up getting is x is equal to, I remember this comes out to be 40. So your answer would be this has to be at 40 centimeters, and so only thing that matches, no, these two match, but then obviously because it's formed on this side from this, so it's going to be a virtual image because the rays of light are traveling this way, image is formed on the same side, so it's a virtual image and the distance of the mirror has to be 40 centimeters. Once you solve that quadratic, you will get a positive 40 and a negative 30. So obviously we are looking for, right, that answer there. Okay, another beautiful question out here. So read this first. A ball is kicked off. So this is a hemispherical stone. There's a ball here, you kick it off. You have to kick with such a speed that it does not touch. Right, so a ball is kicked off horizontally from the top C of a hemispherical rock ACB of radius r on a horizontal ground with a velocity v so as not to hit the rock at any point during its flight. So it just has to not touch that. Choose the correct statement. The ball will just strike at B. That's the first option. Second is the ball will strike at D where this distance is root 2 minus 1 r. Or they're saying, okay, the third option is this distance is 2 minus root 2 r. And the third is the speed v of the ball should always be greater than the critical speed v naught, where v naught is root of gr by 2. Very easy question, honestly. So think about this as a projectile. So when something is thrown in this direction, it's a uniform motion, assuming there is no air resistance. It's v velocity, so it's going to be traveling with the uniform velocity of v. After time t, it would have covered vt. This is a different story. This is an accelerated motion. So after time t, it would have fallen half gt square, right? Equations of motion. So if it falls half gt square, the distance was r to start with. So after time t, it would be at a height of r minus half gt square. So let's start with those things. So I'm saying as a function of time, x is equal to vt, while y is equal to r minus half gt square. Now, obviously, in these kind of questions, you have to understand that time has to be eliminated because we are talking in terms of the coordinate system here. We are saying it should not be striking here. So equations here, you can eliminate t by saying t is equal to x divided by v. So see, this is where conceptual study helps because many times students memorize those equations of projectile and all those trajectory and then don't realize, okay, in this case, it has to be r minus whatever. So do it from the first principles. All you're doing is you're eliminating t by saying t is x by v. So plug it in here. So y is equal to r minus half g t square. T is x square and then divided by v square. This is your y. Now talking in terms of theta, right? So now if at some point of time it is at an angle of theta, so can I say y is r sine theta? Because now what I'm trying to do is I'm trying to relate these things with r because it doesn't have to strike here. So y is r sine theta and x is r cos theta. So let's plug those things here. So this is r sine theta is equal to r minus half g by v square x square. X is r square cos square theta. Here you have sine theta, here you have cos theta, and that to cos square theta. So that's wonderful opportunity to convert that cos square theta as 1 minus sine square theta. So again, I'm not spoon feeding here. I'm giving you the pointers. You try it yourself completely. But let's do the next step at least. We can say this is r sine theta, which is y, is equal to r remains as it is, r minus half g by v square, half v square here, and then to just to be a little cleaner there, I'll just say g by 2v square, and then x square. X is r square cos square theta. So that cos square theta can be written as 1 minus sine square theta. So let's write it here, r square 1 minus sine square theta. Why did I do that? Because now I can clearly see it's a quadratic in sine theta now. Right, because sine theta, cos theta, they would not mix. So why mix and match? Now here you can cross out a few things. You can cross out this r square. So let's do that in this step. You can say, oh, this r goes away. This becomes 1, or that's 1. And then this r square becomes r. Now quadratics are usually simpler if the coefficient of that x square is 1 and here x is, it's a quadratic in sine square sine theta, so sine square theta, let's make it 1. So you take this and you multiply the whole thing by 2v square by r or 2v square by gr, right? What will happen with that is this sine square theta will remain isolated. So 2v square by gr, so let's write it here. We are saying 2v square by gr sine theta is equal to 2v square by gr, right? So 2v square by gr, right? 2v square by gr, and then this becomes minus 1 plus sine square theta. So this looks like a quadratic equation. We'll just beautify that as in x square plus something x plus constant. So sine square theta, and this comes as minus 2v square by gr sine theta. See how beautifully this is turning out to be a quadratic. So this comes here and then minus 1 and this thingy. So plus 2v square by gr minus 1. So this is a quadratic. Now, if you need a real solution to this, then the discriminant, that is b square minus 4ac, has to be 0. So that's exactly you do. So what is b square? B square is this minus 4ac has to be 0. So let's do that. So this needs a real root. So b square, which is this square. So let's wipe this out here. And I'm just trying to save some space here. And again, no spoon feeding here. You try it yourself. I'm just trying to give you some pointers here. So this square will give you 4v4, 4v to the power 4 by g square r square by g square r square, b square minus 4ac should be 0. So is equal to 4 times this. So minus 4, let's write it down, 4ac, c is 1, 4v square, so that's basically 8, 8v square by gr, right, 4ac, so times this plus 1 is equal to 0. Right, so this is what you get. This b square minus 4ac has to be 0. Now we started with the quadratic equation. We are there at v to the power 4. But not to worry. Think about this is another quadratic now. V square by gr, v4 by g square r square. Isn't this some box here and that box square? First of all, let's get rid of, oh, this was a 4 here because 4. Sorry, my mistake, calculation mistake. So that has to be plus 4 because, right? Now, first of all, let's clean this up. This 4 will go away. So this will wipe out 2 and then 1. So this is some box there. This is box. This is box square. So this looks like 2 times uh, v square by gr whole square. Right? This is how I can visualize. And 2 goes away, sorry. So 4 goes away. Minus 2 v square by gr plus 1 is equal to 0. Now, this is simply the case of this minus 1 whole square. Isn't this a square minus 2ab plus b square? So basically, this comes out to be v square minus gr, v square by gr minus 1 whole square. And then you take it on the other side. So basically, what this becomes is this is equal to 0. So v square by gr is 1. So v is root of gr. So this gives you v is root of gr. So once you know, okay, the velocity here has to be root of gr. So this is the velocity with which you will have to throw this ball. Now where will it fall? See, the horizontal motion is simply a uniform motion with the velocity of this, and it takes the time. So let's quickly do that. So wipe this out, wipe this out. And again, it's a very, very lengthy question, and I advise everybody you try it yourself because you are going to learn a lot of concepts in this one question. So what we learned so far, it is moving with a velocity, initial velocity of root gr. That is the initial velocity with which you throw that. In the vertical direction, it is simply a free fall. So free fall, if it falls down freely, isn't it going to take you do so basically it is going to take square root of 2 r by g. This is the time it is going to take to fall down if through that from that height. So this is the time it reaches the ground. In the same time it is moving with this velocity. So how much would it have traveled in that direction? Velocity time, you multiply those. So how much is this distance? This distance is root gr multiplied by 2 r by g. G crosses out. So this is r root 2. This distance is r root 2. The whole of this is r root 2 and this is r. So r root 2 minus r, and what you end up getting is this is the distance. Let's move on to the next question here. A uniform beam of light of intensity. So see how beautifully these questions are so easy. These are all actual questions from the 2024 paper. Okay, by the way, a uniform beam of light of intensity 60 milliwatts per square meter is incident on a totally absorbing sphere of radius 2 micrometers. The density of the material of sphere is this much. The sphere is placed in a region of space where gravitational force can be neglected or ignored. The magnitude of acceleration of the sphere due to the incidence of the light is radiation pressures. Think about radiation pressure. So what is happening here is you have a sphere. You have a sphere and we are saying, okay, let's throw light on this. To accelerate something, you need a force. How do you provide the force? You can push You can put a water stream, but in this case, you are saying let's throw light on this. So if you throw light on this, those photons are striking the object. I mean, in a real life situation, it doesn't matter much, but think about very light objects and a high density, high intensity of light. When the photons are striking here, it's more like the balls striking on this. Wouldn't that provide a force, enough force for this to move? It's very tiny, I know, but it is not zero. So when light falls on an object, the pressure, the radiation pressure is given by the intensity of light divided by the speed of light. So that pressure is going to accelerate the object. Now pressure is force by area. So if we write it as force by area, so that times area goes in there. So this is the force. They're saying find the acceleration divided by mass. And that gives you the acceleration. It is such a simple concept out here. So this is the pressure. Pressure multiplied by the area will be the force divided by mass is the acceleration. Now let's plug in the values. Intensity is given to me. Intensity is given to me right here. Now area, what area? So when you expose this sphere to that intensity of light, that cross-sectional area, this cross-sectional area is the area that we are talking about. So this area can be replaced with pi r square. That's the area. Divided by c, we know the speed of light, divided by mass. They're not given the mass, but they are given the density. So density multiplied by volume is going to be the mass. So let's replace that mass with the volume, which is 4 by 3 pi r cubed times of density. Somebody is continuously calling me. I'll take the phone later on. Okay. So now this r square and r cube, they will cross out. So this r square, cross it out with this r cube. Now this pi crosses out with this pi. And this remains here, this goes on the top. So what you have is acceleration is given by 3 times the intensity, that you can take it from there, convert it into SI units. 4 CR rho. Now everything in this expression is given in the question, you plug it in, and I think you will get the answer as C. I don't remember, honestly I don't remember. You can figure that out yourself. See how easy these concepts are. So, by the way, I also wanted to let you know that we are starting a new course for NSEP, which is going to be happening in November this year. So, if you are interested in joining the course, I'm starting module 1, and the classes are going to be 6 to 7 p.m. every Monday and Wednesday, and there are certain extra classes we do as well. Module 1 is starting on 3rd of February. It's coming up, and its price is only 3,000 rupees, and if you apply the coupon BS Pro 1 you get 10% discount. So the links are below, or you can go to vedantu.com and look for Olympiads and you will find it there, but the links are below, and those links already have this coupon code incorporated. So one module is 3,000 rupees. Total course is divided into 5 modules, that would be 15,000, but we'll give it to you for 13,500. But again, you can still apply that coupon here. So even that price will be discounted. And how the course is divided is something like this. So we have divided into 5 modules, and we target to complete by October, and November is going to be complete revision. So this side is all 11th, 11 JEE 11th topics, and this is all 12th topics. We are going to cover everything, and just wanted to let you know, but I'll be here on this YouTube channel giving you a lot of solutions here. So in next couple of days, I'll be back with next 5 questions. So I'll see you soon, students. Take a pledge that you're going to study physics very simplified manner, no memorization, nothing. So see you soon. Bye bye. Keep up the high Josh.